Here's a second example on recursion, and with this example I'm trying to show how careful you need to be when it comes to recursion and how important it is that you understand how recursion is built when calculating a final answer. And so this method is called beware appropriately because if you don't understand how this is built, you probably are not going to get the right answer. But let's just analyze this method beware first. So beware needs a parameter, an integer parameter. So when I call beware, I need to send it a single integer, just one number. And when I dump that number in, it's going to check it. It says if that number is a 5, we're just going to spit back the number 2. If it's not a 5, we're going to spit back this formula, this math formula. We're going to go 2 times whatever it is, and then we're going to subtract beware a minus 1. So I'm going to subtract a number, but that number needs to get dumped back into this formula, so the method is calling itself again. And we're in this loop. As long as a isn't 5, this thing keeps using itself again. Beware, 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 beware. It keeps going until we hit a equals 5. And so it's important to realize, number one, that if you don't want an infinite loop to occur here where you're just stuck and your program never ends, you need to make sure that eventually a equals 5. Because if a does not equal 5, we're going to have a problem. And notice down here, I'm calling beware 8. So 8 gets dumped in. It's going to be 2 times 8 minus beware 7. And then the next times it'll be beware 6, and then beware 5. And I'll finally get to the number 5 where this stops, because it will not call itself again. Of course, if I put a plus 1 there, this loop goes on forever, because it's beware 8, beware 9, beware 10, beware 11. It will never equal 5, and now I've got an infinite loop. That's one danger with recursion, is you need to make sure that your loop is going to end at some point, or this thing is going to get nasty. So let's analyze. Beware 8 up here on the top in blue. Beware 8. 8 gets dumped in. 8 is not 5, so it goes to the else, and it returns 2 times the 8 minus beware 7. Great. No problems. I have to calculate beware 7. So beware 7 calls itself. It's already in the method. It now calls itself and says, hey, I need to run again because I got to figure out what beware 7 is. So beware 7 calls, beware calls 7, and now we have to realize that beware 7 spits back 2 times 7 minus beware 6. And the method says, oh, wait a second, I got to calculate beware 6 now. So it dumps 6 in. That's 2 times 6 minus beware 5. And oh, beware 5. Dump 5 in. This time when it dumps the 5 in, it says, whoa, here I am. I just want to tell you the number 2, and then I'm done because I don't call myself again. And that's all great. Most people that I see starting to learn recursion get the hang of that pretty quick. But now, if you just follow straight up math from left to right, you will discover that you will not get the right answer because of the way that Java builds the solution. Remember, it's very important that you understand that Java builds the solution backwards. And so what it does, it starts at the bottom of what I've written here. This is actually really nice to write this out if you're solving recursion problems by hand. It starts at the bottom. It says, I have a solution of 2. 2 is what beware 5 is. So it's going to replace the beware 5 with the number 2. And now it does this line of mathematics. It does 2 times 6 is 12, minus 2 is 10. So this answer is 10. Alright, so what I'm going to do is I'm going to take that answer 10, and I'm going to dump it in up here and replace the beware 6, because that's what it is. It does a line of mathematics, and it says I could do this. 2 times 7 is 14, minus 10 is 4. And it's going to dump the 4 in for beware 7. And there it is, and it's going to go, oh, okay. 2 times 8 is 16, minus 4 is 12, and that's what beware 8 is. The final answer is 12. Okay. Now, that is exactly how it builds the solution. That's exactly what you need to understand. Build it backwards. That's the biggest suggestion I can make to you when it comes to recursion. If I were to run back to this step, if I were to work from the beginning down, A lot of times people make mistakes. If they were to write this all out, they would go 2 times 8 minus 2 times 7. So they would go 2 times 8 is 16, minus 14 is 2, minus 12 is negative 10, minus 2 is negative 12. That's not the correct solution. This is not how it works. Uh, in mathematics, you could think of this as a big parentheses around beware 7, and then you'd have to distribute the minus. There's a whole lot of tricky stuff going on there. And so my biggest suggestion to anyone who's learning programming and deals with recursion is to understand the whole backwards process. Just build backwards.